Walter van Suijlekom is in isolation. You're working on something called non-commutative geometry, but this is for the layman an extremely complicated thing. So what does it mean?
So geometry is about shapes, so like this, which is like a sphere or a ball. What I do in my approach to geometry is I try to approach this from a spectral point of view. It's very much in the sense of physics that we use the spectra of frequencies like waves. We look at how these shapes vibrate essentially, given that there's different kind of modes that we can study. Try to understand from these spectra what kind of shapes are we talking about. What is non-commutative about this? And that's because our coordinates, which you could think of as little angles, for instance, let's call them x and y, that they are not so much numbers, but they have some non-commutative structure in them. So non-commutativity would come down to saying that x, y, or yx, for me, would not be the same. So we try to understand what happens if you consider a space, but you only can measure it, I mean, think about this in physical terms, up to a certain resolution, some epsilon, as we like to call them in mathematics. In mathematical terms, something of last year, I mean, it can have an effect in decades from now. So I really hope to develop this more in detail. How can we actually describe these geometries using this formalism, because it's really fresh.